Hi everyone, I'm Alfred. Today I'm gonna talk about convolutional neural networks. We can call it CNN for short. Before we dive into technical explanation of what CNN is, let's take a look at a few remarkable CNN examples. In the past decade, there emerged many outstanding CNNs, such as LaNet in 2008, AlexNet in 2012, and ResNet in 2015. These CNNs have been widely applied in many fields, such as handwritten digit recognition, face recognition, object detection, and etc. It sounds like CNNs can do a lot of things. You might wonder why CNN is so powerful and versatile. Now, let's unveil CNNs and take a look at the magic behind it. First of all, let's look at the simplest case, which is 1D convolution. There are several concepts we need to understand beforehand. The first one is kernel. It can also be called weights or filter. Kernel plays a key role in CNNs. It represents how much the given input weighs to the output. Let's take a look at the left figure. The gray row is an input layer. The yellow row is an output layer. The green lines represent weights. So each output element is just the multiplication and summation between the inputs and the weights. So just a few fundamental mathematical operations. The second concept here is stride. It means the step size the kernel moves over the input row. In the left figure, the stride is equal to 1. It means the kernel moves one element each time in the row. And in the right figure, the stride is equal to 2. It means the kernel moves over 2 elements in the input row each time, which is quite obvious. Now let's take a look at 2D convolution. The concepts here are exactly the same with 1D convolution. What's different is that there is one more dimension. The input is two-dimensional, which can be expressed using matrix. The kernel is also two-dimensional. The kernel now moves not only in one direction, but in both directions. The mathematical operation is element-wise multiplication and summation, as we can see in the figure. Therefore, the output is a new matrix, which is called feature map. Now we understand what CNNs are. Let's dig into why it works. Let's look at the right figure. It's an image with just a curve at the center. The left figure is the matrix expression of the right figure. Now we're facing a detection problem. We want to design a kernel so that it can detect the curve in a given image. So the requirement for this kernel is that it should generate a high output value for this curve, while a low value for other shapes. Now we are clear of what kind of kernel we want. We can manually design it. The original image here is a mouse. Now we want to recognize the curve in this mouse. The purple matrix here is the kernel we designed. Now let's move this kernel over this whole image. And it moves to region 1. The pixel matrix here multiplies with our kernel matrix, and the output value is 6,600. When we move the kernel to region 2, the output is 0. So finally, after the kernel finishes scanning the whole image, the highest output value will be out of region 1, which is the kernel we want to detect. In a real project, the inputs will be more complex. Take image, for instance. Each image might have 3 channels, RGB. Just one kernel might not be enough to capture all features of the input. we need much more kernels to extract features of the given image. So the right figure is the visualization of different kernels. Each kernel is designated to detect a specific feature, like to detect the edges, to capture the color features, and etc. Secondly, we might need more convolutional layers. Layer by layer, we can extract high-level features. So therefore, the majority work to build up a CNN is to design kernels. But that is to say, how to update the values in the kernel so that it can detect a specific feature. This process is called training. Before training, the values in the kernel are randomly generated, so the kernel cannot detect anything. During the backward process, the values in the kernel are updated, and it can better extract features. After being fully trained, the CNN now can perform a specific task, either for classification or detection. So here is a whole picture of a CNN for image classification. Each convolutional layer here is designated to extract a certain level of features. And finally, together with other types of layers, like a ReLU here and pudding layer here and fully connected layer here, it can distinguish different objects. Hope my explanation can help you better understand CNNs. Thank you.